In this introduction to Doubly Linked List, I will simplify the concept of Doubly Linked List using some animation to help visualize and get an idea of what the code for Doubly Linked List does before I show you the code. And I will explain the code as we get started with the project setup for the Doubly Linked List project. In this video, I will cover the introduction to Doubly Linked List, and this will be the first video of the data structures Doubly Linked List playlist. After this video, you will have a good introduction to Doubly Linked List, as I will define what a Doubly Linked List is and go through the structure of the Doubly Linked List, and really just show you how this works by going through an example, and I'll be using some illustrations and animations so that you are able to see what I'm talking about. I'm also working on the next video about adding a node to a Doubly Linked List, discussing the theory and showing you what the code does, and other videos on data structures concept. So I strongly suggest that you click the bell next to the subscribe button so you won't miss anything, and subscribe to the channel if you haven't, and welcome to ACoreFundamentals. So what is a Doubly Linked List? It is a node-based data structure. A quick definition of a data structure is that a data structure is a way a computer organizes data mainly to improve efficiency. So with Doubly Linked Lists, we have a sequence of nodes linking to one another. But before I show you how these nodes work together to create a Doubly Linked List, let's get a quick revision of the Singly Linked List. And if you're not familiar with the Singly Linked List, I have a playlist that will give you an idea of how they work. And I will leave a link in the video description below. In the Singly Linked List playlist, we have established that a Singly Linked List can be created using nodes, and these nodes can hold two types of information. First being the data we want to store, which can be an integer for an example, and a node pointer that can point to the next node in the linked list. When you use these pointers in the nodes to connect to each other, you get a linked list. In this example, we have a node at the memory location 1010 and can store data, and it has a next pointer pointing to 1020, which is the memory location of the next node in the linked list. And if you understand the Singly Linked List, then the Doubly Linked List will be very easy to understand. So if you want a quick refresh on the Singly Linked List, you can check out the playlist I linked in the video description. So let's get started with the Doubly Linked List. Now, from our earlier definition of the Doubly Linked List, we described it as a sequence of nodes linking to one another, just like in the Singly Linked List. But unlike the Singly Linked List nodes, the nodes for the Doubly Linked List can hold data or information to be stored, a next pointer to point at the next node, and a previous pointer to point at the previous node. So consider a node at memory location 1010. It can store data and has a next pointer pointing to 1020, the memory location of the next node, and the previous node pointer pointing at 1000, which is the memory location of the previous node. Let's look at how these nodes create a linked list using code. Okay, so we have a node that can hold data and two pointers. The way we can create a node in C++ is to use a class or a struct. Both of them get the job done, but we will use a struct. And so we'll create a node by typing struct node. And inside the curly braces, we declare the int data, which will be our integer variable that will hold data. And then we declare the next pointer, and it is a node pointer. That's why we have node star before the next variable. And we also declare a previous node pointer, and that is our node. It can hold data and point to other nodes. And now the constructor function, which will initialize the data variable, the next pointer, and the previous pointer. This function takes in an integer value, which will be the information or data we want to store. And the constructor will set the value of the information to be stored to the data variable we declared. After that, set the next pointer and the previous pointer to null, as they will be initialized to null when a node is created. And that's it, we have a node. So now that we have a way to create nodes, So we can create a doubly linked list, which is just a sequence of nodes linked together. And we create a D-linked list struct, which will be our doubly linked list. And for our constructor, we only want to create a head node pointer, which will be initialized to null when an instance of a doubly linked list is created. We will discuss the code for the deconstructor in the coming video, but for now we've covered enough to get started with an example just to show how these nodes work together to create a doubly linked list. I still have the node constructor so that it's easy to see how everything works when a node is created. And in a moment I will show you the doubly linked list project setup, and I will code the base or foundation code for our doubly linked list project. But for now, I want to make sure that you're able to visualize how this works before we test our code with examples. So initially we have a node in our doubly linked list with data value of 1, and both next and previous pointers are currently pointing to null. And we will create a node we want to add to the doubly linked list. Say we want to store the value 3. So we will create a node that will hold the data 3. We create a node pointer n, which will hold the returned memory address of the newly created node. And now that we have access to the newly created node's memory address, we can set the data variable to 3 and set the next pointer of the previous node to point to the newly created node. And then set the new node's previous pointer to point at the previous node at memory location 1000. And we just connected the first two nodes. Let's add another node with the value of 5. Then a node with the value of 5 with both next and previous pointers pointing at null will be created. And we point the next pointer of the previous node with the value of 3 to point to the newly created node at the memory location 1020. And then the previous pointer of the newly created node to point to the previous node at memory location 1010. And we have connected all 3 nodes. So for this project I'll be using VS Code just like we did in the singly linked list project, and we need to create 3 files. First we'll create the doubly linked list.ccp file and the doubly linked list.h file, which will be the header file, and finally the main.ccp file, which is where we'll test our functions. Now to get started with the doubly linked list.header file, this is where we'll create our doubly linked list class, and where we'll define our functions and our function prototypes that we will use in the doubly linked list. Now I'm just setting up the project here. Okay, so now we can get started with including the usual preprocessors, which is the iostream, the header file, and we'll also include the C standard library. Now I will define the node of the doubly linked list, and as we've discussed in the animation part of the video, I'll be using the struct. Now the node holds an integer data and can hold the next pointer and the previous pointer, which will be 2 node pointers we'll be using to connect to the other nodes inside the doubly linked list. Now for the doubly linked list, we'll only create a node struct, and then we'll create an integer data variable and a node previous pointer and another node next pointer. And now for the construct, which will be called every time an instance of a node is created. Now the constructor function will only take in an integer value, and we want to set that value equal to the data variable we declared. And I want to initialize the previous pointer and the next pointer to null every time we create a new node. And that's it for the node. Now let's create the doubly linked list class. For this we'll be using a class, and we want to call our class the linked list for doubly linked list. And for this class we only want to, in the public section of the class, I want to create a node, a head node pointer, and I want to define the constructor function of the class. Inside the doublylinkedlist.ccp file, which is where we will actually define the functions, we will include iStream and also the C standard library. Now we'll be using the namespace, or before that we want to include the header file which is created, which is the doublylinkedlist.h file, and then after that we can type using namespace.std. Now first create the doubly linked list constructor, and for that we only want to set the head node pointer equal to null every time an instance of a class is created. Now in the main.ccp file we want to include iStream and also the C standard library. Now we only want to include the doublylinkedlist.ccp file. Now using namespace std, and we're also using namespace std. So, and we want to create a main function. Now for this function we only want to output the message we're good to go, so that we know that we don't have any errors in our program. Now we want to compile and test if and it seems like we have an error. So inside the header file we forgot a semicolon, and this should be a comment. Okay, let's clear this and compile again. Now we have an executable. As you can see, let's run the executable file 8.exe and we're good to go. But what happens if we want to add a node at the head of the doubly linked list, or somewhere in between the nodes inside the doubly linked list? Well, in the next video I will show you how to add a node in different positions of the doubly linked list, and I'll make it easy as possible using some examples, and I will leave a link to that video along with the other doubly linked list videos in the video description below. And now that we have an introduction to doubly linked list and we have an idea of how the doubly linked list works, we can now move on to discussing adding nodes to a doubly linked list, and I will be discussing the add node functions and giving you an idea of how they work. Now please take only just 10 seconds to click the subscribe button, because it helps me to grow this channel, and while you're there, just turn on notifications so you don't miss any videos that might help you in the near future. Thank you for staying with me until now. You can support me by checking out my Patreon page. I'll leave the link in the description, and welcome to ACoreFundamentals.